Hi, this is my video on how to use the chain rule for differentiation. So as far as the main differentiation techniques are concerned, we did the power rule, the constant multiple rule, and then the sum rule and the product rule and the quotient rule. And also we learned how to find the derivative of the trig functions and exponential and natural log. But this is a technique which is really important and it's impossible to do differentiation without knowing this technique and chain rule. And I'm going to show you what chain rule is, but I'm going to actually show it in a different way, the technique, right, than the way that traditionally when it is taught in calculus, how to use the chain rule. But let's first of all, let's try to understand the philosophy of this. Suppose we have a function like this to differentiate y equals 1 plus x squared to the power 2. So 1 plus x squared, which really means is 1 plus x squared times 1 plus x squared, right? Okay, it's a product. So now if you take this product, okay, and because we only know the product rule, we can think of it as a product, and then we can use the product rule. So write one, right? 1 plus x plus derivative of 2, diff 2, right? 2, and then write 2 at 1 plus x squared, diff 1, right? 2 diff 1, right? Okay, and the derivative of 1 plus x squared is 2x. So we get this, and if you follow this, we get 2x plus 2x cube plus 2x plus 2x cube. So altogether we get 4x plus 4x cube, and we got the answer. So we need to file this first, and then so we need to so not file this, but we need to use product rule and then file it and get the answer. So now here is a different way of doing the same problem. Okay, so again we do the same problem. So what I want to do is now, in the old video games, which came up in the 70s, right, or 80s, I don't know whether you ever are, sometimes, you attack a castle or something. Okay, so if you just think of, so the thing about attacking a castle is that when you attack the castle from outside, okay, you don't know what's inside. You only see the wall. The inside is kind of blocked out. It's black boxed. So if you think of it as a castle, if this as a castle, then the inside 1 plus x squared. From outside, if you look at, nobody will see the 1 plus x squared. From outside, you will only see the 2 as the square. So you only see a power. Okay, so what you do is you do the thing that you see from outside. So if you only see a power, right, you take care of that. So what you do is you use the power rule. So it's 2 times, because you don't see what is inside. You just kind of put junk here, right? Okay, just repeat that, right? Black box it, right? And then the 2 becomes 1. Okay, so that's 1. Okay, so what it did was really use the power rule to this, right? Ignoring what is inside. So it's 2 comes up in front, 1 plus x squared to the power 1. Okay, and then you're not done yet, because it's like in the when you attack the castle, first you attack the wall. So you just attack the wall here. Okay, but once you attack the wall, the thing that you do is you look inside. You look at the next layer. But you forget the wall completely, because the wall is now done. So this square, you forget about it completely. Now you only look at the inside. So what is inside? The inside is 1 plus x squared, right? The derivative of that would be, the derivative of 1 will be 0. 1 derivative of x squared will be 2x. So just 2x. And then we are taking care of the inside, this part. There could be another inner chamber, right? Okay, but unfortunately for us here, there's only one inside, right? Okay, and we took care of that, and we multiply the previous part with what is inside, and we keep going inside. So we go work from outside, and we black box the insides, and then we take care of that berry, and we go inside and take care of that and take care of that and keep on doing it. So if you now kind of simplify this, you get 2 times 2x is 4x. So if you file this, you get 4x times 1 is 4x, and then 4x times x squared is 4x cubed. You know this, that you get the identical answer as before. And then you might think, hey, you know what, if you're getting the identical answer, why not do this one instead of, because that's straightforward product rule instead of learning this new thing. Well, let's do a small variation on this problem. So now if you take 1 plus x squared to the power 7, and if you want to find dy or dx, right? If you are trying to use product rule here. You need to have 7 products, and you need to take these 7 products and use this product rule over and over and over and over again, and it is going to be a pretty exhaustive, like pretty long and cumbersome calculation. And if I put 50 here, it'll be pretty much out of, you'll be working for a couple of days, right? And so you see that the product rule actually is not, it fails, it has its limitations when it comes to slightly complicated powers like 7 or higher powers. So how do you find the divide? Well, you can still use the chain rule. Well, first of all, look at this as a castle. What do you see from outside? You only see the 7, you don't see this. So take care of the 7. What you do is the 7 comes up in front, and the inside is black box, and the 7 becomes 6. Okay, so we took care of the outer wall. Now we forget about the outer wall completely. We completely forget about this power 7, and we go inside. And what is inside? We see 1 plus x squared, and we differentiate that. We get 2x, and you simply multiply by that. Bang, you're done. So 7 times 2x is 4x, and 1 plus x squared to the power 6. So it's a very easy technique to do once you get the hang of it. Okay, so as an exercise, I will leave you to this problem, right? So I want you to now pause the video and do this on your own. Okay, when you come back, let's try to see whether you do it right. And then what will you do? What will you see? First of all, you have some kind of a junk to the power 50, so you don't see this part at all. You take care of the 50, so 50 comes up in front. So 50 times that whatever this junk inside. So 50 times 1 minus x squared plus x cubed, right? 50 times 1 minus x squared plus x cubed, right? Okay, and the 50 will then become 49, right? Okay. 49, right? And then we have taken care of the 50. Now we completely forget the 50. We concentrate. We are done with the wall of the castle. Now we only look at what is next. What is next is we have this polynomial type thing inside. So we just differentiate that. So when you differentiate that, what do you get? You get 0 minus 2x plus 3x squared. So we have 3x squared minus 2x, and we simply multiply the previous part with that. Okay, and then I guess you can take an x outside from that, and then that becomes 50x. So this part is there, and if you take the x out from that, you get 3x minus 2. So that's your answer. Well, you need to practice this a lot, and so let's do this one, right? So I'll leave it to you. Once again, pause the video and then do that. Now let me give you a hint before you pause. So you have 1 plus x squared to the square root. Remember, square root is a power. So this is 1 plus x squared quantity to the power 1/2, and then find dy of dx. Okay, pause the video and then do it. And then when you come back, right, okay, let's see what you have. So it's 1 plus x to the power 1/2, right? Okay, so 1/2. So from outside, the outside wall, you only see the square root or the 1/2 power. You don't see this. So you black box this, okay? So the 1/2 will come in front, and then whatever that you black box to 1 plus x squared, right? And the 1/2 will become negative 1/2. You subtract 1 from 1/2, right? When you subtract 1 from 1/2, you get negative 1/2. And then what you do is you're done with the outer wall. So I'm done with the outer wall. You're done with the square root. The square root is no longer there. So what you go is you just go inside. And when you go inside, you get 1 plus x squared, and the derivative that is just 2x. And you multiply that by 2x. So we can kind of simplify this a little bit. The 2 and the 2 cancels off. So the x is there at the top, and the 1 plus x squared quantity to the negative 1/2 power, it goes down as a positive power is 1 plus x squared to the positive 1/2, which is the same as 1 plus x squared square root. Okay. So let's do another one before we end this. Maybe we'll have to do a second part for this video, but at least we'll try to end the first part. So suppose we have cosine squared 2x and find divided. This one is a pretty tricky one, even though it really looks very simple. Now, if you look at from outside, what is the outer wall? Certainly, it's not the 2x. Then somebody might think, is that the cosine? Is cosine the outer wall of the castle? No, really, outside the cosine, there is a second power. So if you're looking at the castle from outside, you only see the 2. The cosine 2x is black boxed. So you have some junk to the power 2. So you take care of that first. So the 2 comes up in front. So 2. And then inside, you are left with cosine 2x. So 2 cosine 2x. So black box it. And the 2 becomes to the power 1, which we don't really have to write. So but if you really want to write, you can just put 1 here. The power 1. Right, okay, and then what you do is you go inside. If you go inside, now we forget about the 2 completely. You have taken care of the wall. You're only concentrating on inside the castle. Now let's look at inside the castle. You get cosine 2x. No, really, you don't see the 2x. You see only cosine of some other black box. So what I'm trying to say is that this castle has 3 chambers. First chamber is the 2, second chamber is the cosine, and the third inner chamber is the 2x. So we take care of the 2. Now we take care of the cosine. So we take care of the cosine, we get negative sine, right? Some chunk, right? Okay, or negative sine 2x, right? So negative sine 2x, okay. So we are almost done now because now we are past the cosine layer, and now we are stuck with we have one more layer, the innermost chamber of the castle, which is 2x, and we need to differentiate that, and the derivative of that is 2, and multiply by that 2, and then you simplify that, you get this is just to the power 1, so it's the same as that, right? Okay. Yeah, write the one. So 2 times 2 is 4. Negative 4 times sine 2x cosine 2x. Negative 4 cosine 2x sine 2x. As an exercise, I would like you to leave you with this problem, right? Okay, and pause your video and then write that. All right, and find the derivative, right? Okay, and when you come back, I leave it. Okay. Ah, so you come back. So first of all, what do you see from outside? You don't see this is black boxed. You only see the 2 from outside. So take care of the 2. So it's 2 times this junk here, e to the x minus 1 over e to the x plus 1, right? And then you go inside, and then you go inside, you say e to the x minus 1 over e to the x plus 1, right? Now you don't worry about the 2, 2 is gone now. You only worry about the inside, which is actually a fraction. So what you do is you just use quotient rule for that. So it's Lodi high ex plus 1 times times the derivative of e to the x minus 1. The derivative of e to the x is e to the x. So it's e to the x plus 1 times e to the x. The derivative of 1 is 0. So e to the x plus 1 is times e to the x minus e to the x minus 1 times the derivative of the bottom is e to the x, right? Okay. And then divided by e to the x plus 1 quantity squared, right? Okay. So if you do that, right, you get e to the x minus 1. So if you simplify this, simplify this slowly, I'll leave it to you and you should get this answer. That's it for this video, and then we'll probably see whether we need a second part for this video, but at least this is good for a first part. Thank you very much for watching.